So yes, thank you.
Yeah, so I'll show you some work we are doing. This is state of the art, and some of that is not yet even published. But it's, I think, good for you to see what is currently going on. And I will focus a little bit on the way we use large language models to do that type of research, because I think this is the overarching theme of the school. And then towards the end, I'll give you this little exercise tasks that I shared. So that is actually quite, I think, hopefully easy to do and for you to explore. So I share my screen and I have some slides with me. So there it is. So I will stop seeing you when I share the slides. So you have to interrupt me with audio in case there are questions, yeah?
Of course. Yeah.
Good. So let me just know if you have some. Oh, I actually still see you, so don't worry.
Yeah.
um,
Yeah. Full screen. Now we can see everything wonderfully perfectly. Yeah.
yeah. Okay, perfect. Okay, so computational social science for studying digital democracy. As Akin has already said, is that I'm in the Center for Synergy of Systems, and that's a complex systems center. So we are interested in the complexity of all of it. And complexity means a very simple thing when it comes to online communication, at least in my understanding. As you all know, we have been part of a more simple information system where most of us were recipients of information and there were only a few senders. So you can also call this a one-to-many system or few-to-many, where there are a few newspaper a few newspaper outlets, a few television channels or radio stations that are sending the information out and we are receiving it. But with online technology, that has changed quite dramatically. As we all know now, with our smartphones, we are not just receivers anymore, but we now are also, we can send information ourselves, we can forward it to others, we can react to it, we can comment, and we can produce our own outlet, like news outlets, basically. So people can become influencers and producers of information. And that is where the whole separation of roles became a bit blurry. And we moved from a system that is, as I said, one to many to many to many. And at least in my understanding of complex systems, I don't know if you have come across the term, it is this property that makes a system complex, which is that there are many interacting parts. Yeah, whenever there are elements that are interacting with one another and then they produce something that is bigger than just the sum of their parts, we have a complex system. And I think our information world nowadays is very much a complex system. In addition, of course, we do have algorithms that are here at play that help us navigate the system. So this is another element that has like a complex property, which is a learning system, and it can update and has introduced this feedback loops between us and the algorithms. So we have a lot of properties of complex systems. So we have network structures. Yeah, people can connect with anyone else. We have feedback loops that are these reinforcing loops of us interacting with algorithms, for example. We have also emergent phenomena, which are things like a viral post that wasn't posted by a authority or like a big television channel, but by someone. And then many people with their individual actions, they, in a collective process, then made this a viral content. And that's a good example of what is often called an emergent phenomena. Yeah, something that emerges from the individual actions. And we do have a strong coupling between the micro and the macro layer. So it is not like it used to be that the big elites, they basically can decide whatever the information reaches the public, but it's much closer to people talking about things that can reach the politicians and vice versa. So we have a stronger coupling between the scales, which I think is another interesting aspect of that. Of course, now There's another element that has been added to the complexity of the system, and these are bots that are basically populating this area. So they are part of our conversations now when we look for information, but they're also part of the social networks here and there. If you think about Grok being active on X and being an actor themselves, this adds to the whole complexity of it all. We did not yet understand the complex system before of social media, and now we have bots that make it even more difficult. So I'm wondering how things will look in another few years. But yeah, I'll try to tell you what we are trying to do to understand what we know for now. It's also important for my view on these systems just to say that this is, of course, all technology. And that technology is not just happened to us. It's not that this transformation is just like a natural force, but actually there are companies who are building this infrastructure and all this technology. And what is always important to understand is that they have their own goals, right? So they want to earn money most of the time. And as we know, there are some of the most valuable companies in the world are to some extent dealing with this in this world, in this digital infrastructure. Okay. Yeah. And of course, very prominently, Elon Musk and also Mark Zuckerberg, after the takeover of Trump, have indicated their political, let's say, ambitions. Okay. So now, what can we measure actually? Mm. And I think this is kind of what I'm trying to do in our research, and I want to give you a bit of a high-level overview of that. So we can only measure what happens on the surface of the public debate because we cannot really look into the platforms, unfortunately. We don't know exactly how they work. And still we don't know that. So we have to measure what's really detectable on the surface. And this is a study that my PhD student Pietro did, and it's I think a very substantive measurement of all types of news headlines around the world. So we collected 40 million news headlines from 20 different countries. Many of them can be actually accessed via APIs, like the Times of India or the New York Times and ABC Australia, for example. They do have public-facing APIs. And we could collect that type of data for over 20 years. And then a very simple language processing technique, maybe you have heard about this before, is sentiment analysis. So there are methods to measure the sentiment of a text. And in this case, you can distinguish, for example, between a negative headline and a positive headline. And you will do this in the exercise. So basically, part of that is to compare the sentiment over time of two different topics. And here we did that with news outlets and the headlines of them. And what we see is that there is a slight increase, and it's not that small as you may think, because the y-axis is 100%. So what we saw in the last 20 years is like a 15% increase of negative headlines. And this trend is a bit stronger for right-leaning outlets than for left-leaning outlets. And we do have like a counter development, which is a slight decrease of positive headlines. And I think 15% of an increase and a decrease of positive and negative headlines, respectively, is something that we might want to consider as like a remarkable observation, because it may mean that there's something changing in the way our newspapers and our whole information space works. It becomes more negative. But we can actually go a bit deeper, and we could go into more text data, because the large language models now allow us to do this more than just sentiment. Positive and negative is relatively simple. But if we use large language models, we can go to more complicated constructs. for me, in my view, it's not so easy to replicate this as in an exercise now, because what we do is we use open source large language models that we can run locally, which I think has a lot of advantages. But this is only possible if you have a lot of compute power. I didn't know that so much, but actually these models do require really a lot of compute power, especially GPUs. And sorry, I just realized there's some text in German. So to translate is what we did is we collected data from 3 different platforms, which is Instagram, Facebook, and X. And we collected that stood out. And these are these types of rhetorics. We call it divisive rhetoric. So one thing that we could measure a lot is us versus them framing. So if a text contains the 2 groups that are being pictured as us and them, that is what our large language models can detect. And we do see like an increasing trend of this type of speech in France and in Germany mostly, in UK not so much, and in Poland a slight increase as well as a high level to begin with. So the darker the colors, the more present the posts are in political speech, and that over the years. As well as what we found is like negative emotions. So if there's a post talking about something that is a threat, yeah, so that people should be feared for, we see this increasing as well as outrage. Outrage is usually done in a way that people talk about a moral a breaking of a moral norm, right? So that someone behaved in a morally outrageous way. But this is not the most concerning. So we see that this exists in political communication of members of parliament in all those countries, and that there are some trends increasing. But what is probably more worrying is that we do find very strong correlations with engagement. So in this case, it's the number of shares that a post gets, independence on how much of this type of rhetoric is being used. And as you see in all the 4 countries, and across all politicians, by the way, and across all political parties, even though some use it more than others, we do see a very strong positive correlation with using more of that type of language, which we, as I said, call divisive, and the number of shares they get. So this is quite concerning, and that is, by the way, a logarithmic axis. So this increase is stronger than you would even think from that figure. So we do see that in current information systems, like social media, apparently this type of language has a big advantage. So it seems to be much more successful than what you would expect otherwise. And certain parties are profiting from that. So in Germany, we have a populist party, which is the AfD, and their chancellor candidate is Alice Weidel. So we looked at the visibility of the different chancellor candidates during the last German election, and we did find that Alice Weidel was always amongst the top visible people on all these 4 different platforms, so Facebook, TikTok, Instagram, and X. So there seems to be some generalizable thing running. And this is not just true for Germany. There are many countries where they study the success of populist parties on social media, and there seems to be something going on because populist parties are often more successful there. And we do think that if we look at the findings before, that it might have to do something with the type of language they're using. If you happen to know some psychology or studied psychology, maybe this is not a surprise for you, because negativity, as well as us versus them, and negative emotions, emotionality, is known to catch our attention more quickly. And as we live in an attention economy in these platforms, I think it's not the biggest surprise that that type of language works well. Yeah, we see this, by the way, also more specifically on X. X, as you know, has been taken over by Elon Musk. And we did see that when Elon Musk started to be interested in German politics, the number of followers of the AfD candidate Alice Weidel, for example, has doubled in that time. So on the left, you see a plot of her follower numbers between like end of December, early January, so just a few days during the election cycle. And she managed to increase her follower numbers from 500,000 to 1 million. And that was exactly the time when Elon Musk also was kind of posting about her and getting interested in her. So it is relatively plausible that this has helped her a lot. So we also have to ask what these platforms mean for political power, right? So we have built a system where this kind of language is working very well. And we see that the owners of these platforms, they also have a political interest. So I think we live in a very, let's say, a delicate time where the way we communicate work happens on a platform that is controlled by certain companies that do have that are not neutral. I think that is the main important insight. They do have interests, and with Elon Musk, I think it became most visible. And we can measure it when we use computational social science method like this one, where we look at the visibility and the follower numbers on those platforms. I want to show you one more application of large language models in computational social science that I find kind of innovative. And there's a preprint about this that we just have recently updated. And the logic is relatively simple. So far, I don't know if you have heard already talks about misinformation or fake news. And one big challenge is that we want to measure the prevalence of misinformation. And it is very difficult to do that because it may need a judgment about the content. And one thing that people did is they looked for URLs, so links to untrustworthy websites. And I don't know about Turkey, but I know that in many countries there exist fact-checking organizations, and they do rate also outlets. So, for example, there are certain outlets that are listed as untrustworthy because they have repeatedly posted false information, for example. So you can then go and look for those kinds of outlets in the URLs. But of course, what you miss is all the posts that don't contain URLs. And politicians often, they write something, they say something, and it does contain misinformation, but you cannot detect it because it just is in the text. And if I would say that large language models are good at something, I think they're good at text. So they can deal with a lot of text and complexity of text. So that's what we used here. And what we did is we took all these posts from the politicians that you already know from the previous study. So many politicians from different countries saying things. And then we combine this with fact checks. So there are these fact checks in Germany. There are also elsewhere where you get the claim that has been checked. So there's a claim, I don't know, windmills kill whatever, whales. And then this claim you can extract from the fact check article usually. And if you combine those, you can build an embedding space, and an embedding space where you find claims that are close to one another. So if there's a post from a politician and a claim from a fact check that are close in the embedding, so meaning that they are semantically similar, saying something related, then we do an LLM matching, which means we ask the LLM, are these two pieces of text saying the same thing? And that works relatively well. So if we compare this with human judgment, we get like 80% accuracy. And that allows us to look relatively precisely for claims in free text and to count how often, for example, politicians have made claims that have been previously fact-checked. And this is one, so the good thing is we can count them. We find that it's like in the one-digit percentages in Germany, but that for some topics and some parties, the number goes quite up. So during the pandemic, for example, there were a lot of false claims being posted by the right and the far left parties during that time. We can also do more other things. So what we can do is now, because we can track the claim in the text, we can do this across platforms and over time. So we are not bound to a specific post, but we can also look for the claim if it appears elsewhere. And this is what we did here, and this is data from the US with the same method. And we see the order of appearances of claims that are false. So fake news, basically. And what we see is on the left, the first appearance of a claim and that is later being fact-checked is often on social media. So we see on Facebook and X specifically, the most appearing the first, and then they appear another time on social media, and slowly the media is picking up. So media is the green one. It's being reported in the news, and then only very late it's being picked up by the fact checkers and they check it, which may already be too late. And the origin is often social media. So this is another type of information that we didn't have before. We had this type of method that is supported by LLMs. We see very similar patterns in UK and in Germany. So it's always social media first, then the news, and then the fact checks. So it's a bit of an unfortunate order of events, I would say. Okay, let me jump a bit over this and come to a more, let's say, a conceptual point. So we can measure all these things, and that is very interesting. So we see that there is this type of emotional language. We see us versus them. We see political parties that are more extreme and more populist, that are very successful on these platforms. And these are all things that are potentially very concerning for democracies. So, of course, populism in its form of the pure people against the elites is anti-pluralistic, and you can argue from a liberal democracy point of view, it is an issue, for example, as well as affective polarization and other things that can come out of this type of divisive language. And then we have also disinformation, false information, like I just showed you the data that is being used by politicians, and we can see that it starts at social media and so on. So maybe there's a problem, but the problem is that we are still only looking at the surface, and we can only measure correlations. And as you know, in science, we often want causation. So we want to understand what is driving things and not just what things are occurring together. Because there are still people who can say, yeah, look, but this type of language is it's not being caused by the platforms, not by social media. It's just what people like. It's what they do anyways. And so now the task is to prove that there is actually an influence from the technology on people's type of language and behavior. And that is very difficult. That is a really, truly difficult task, because I think slowly the field is coming to like insight that there's probably some dangers for democracy that are being caused by social and digital media, maybe also by chatbots, because now people ask the chatbot, what should I vote for, and things like that. But the big question remains the causal question, and not just the direction, but actually the mechanism. And I think we are rather at such a point. So people are arguing in my area rather about the question, is it like that the algorithms of the platforms and also the chatbots that are favoring certain types of positions and certain types of language, and that they are pushing this, and that's a problem for democracy? Then there are others saying, oh, it's actually the bad actors in the world, all the autocrats that are now using these technologies to be a danger for democracy. Other people say it's the classical media that doesn't really deal with cannot really deal with the new digital world and with the business model, and we lose them, and that's a problem. And finally, there are two things that I really want to emphasize. There's the other point that it may be selection effects. It may be that on social media, there are just very few people who are very extreme are visible. We do know from research that only like 5% of the people are actively posting content. And that those 5% are politically more extreme than the rest. So it might be actually that being the driver. And then the end, finally, of course, many people say it's actually us, it's our psychology. And that is wired to like this kind of rhetoric and to hate the others and all these things. And so I think these are the open questions at the moment, and we are trying to work on them. So just to give you a feeling for where the field stands. And in reality, those are, of course, also interacting with one another. So the actors, they're using the algorithms for their benefit. Psychology is coupled to the algorithms in a way that they adapt to our preferences and so on and so forth, making it a very complex system again, as I started with. And now, in order to find a clearer picture, and in order to get rid of some of those errors, we need experiments, in my view. So I think we need ways to test some of those connections. And ideally, we would change something in the platform. We would change the algorithm and see what happens. And if we see then hate speech goes down when I change the algorithm, then maybe there's something going on. But running experiments on platforms is very difficult. So unless you are Facebook. And there was a big series of papers that came out, I think, 2 years ago now, or maybe even 3, that they were published in like the major outlets in Science and Nature and so on. And it was interesting because there was half of the authors work for Meta, and this was done together with Facebook. And interestingly, the findings, they all suggest that Facebook doesn't have a causal effect on polarization. However, there were also some issues that being uncovered because there was a pre-processing step, for example, in the data where Facebook was involved and the researchers didn't have full control, as well as that the algorithm was tuned down during the study period. So I think these are impressive studies, and they are actually well executed. But I think they have this inherent problem of being having a conflict of interest because Facebook, of course, themselves don't want to be responsible for polarization. And yeah, that's why we need alternative ways in our field. And I just want to point you to one thing, and that's the DSA. So in the European Union, we do have the Digital Services Act, and that actually works even outside of the European Union. So if you work on computational social science and you want to study societal risks, then you can go through the DSA. So you can write an application to the Irish authorities and ask for data from platforms. And this is called Article 40 in the DSA. If you are into law, you can read it up. So Article 40 says that researchers should have the access to data to study platforms and their societal impact. You have to study societal impact. So you need to look for disinformation and polarization or other things like dangers for health. But then in principle, you can request data because maybe you have already heard about this. We live in a bit of a data poor time because the platforms have closed a lot of their accesses because of large language models that being trained on their data. So Reddit, for example, used to be open and now it's closed, as well as other platforms like Facebook doesn't have CrowdTangle anymore, and so on. But the DSA in Europe, Digital Services Act, is reopening some of those again. And now you can, for example, apply for researcher access at Reddit. So there's a Reddit researcher access way if you want to work with that data. One discussion that I'm following is if ChatGPT, so OpenAI, will be classified as a big platform or search engine under the Digital Services Act, because then it would mean that we can also request data from ChatGPT. And then we could study how people use ChatGPT, which I think is crucial for our time, because things are moving fast, and now people using these tools so much that we need to understand their societal impact as well. So just to encourage you that in the future, maybe we can actually get more data from platforms like ChatGPT, from bots. Okay. So for this overview, I'm coming to an end and saying that I think the only thing that will save us from this complex task and the complexity of the system is what I call epistemic pluralism. So we need various methods to study these systems. We cannot just rely on one big experiment or one big theory or the observational data, but we need all of it. And I think about it often as this axis between experimental control and ecological validity. That means on the very right side of this spectrum here in observational data is what I showed you in the beginning of this talk. Like, these are things where we can measure the real world. It's very ecological valid. So it's real things, it's real politicians saying real things on real platforms. But we have no control. We cannot say anything causal because we can only observe. We can only see what they are doing there, but we cannot really change something and then see what happens. On the other end of the spectrum, we have experiments where we actually control some of the environment, where we can, for example, have a social media type of experiment, and we can change the way the content that is being shown to people. And we gain a lot of control because then we are the experimenters and we can change things. However, we are losing ecological validity because it means we cannot suggest that or assume that what people do in such a very artificial experiment will actually happen in the real world. So I don't know what people do on their sofa in the evening when they scroll social media. It's probably very different than if they sit here in my university lab and do an experiment or something like that. So there's a fundamental balance, but with computational social science method, and I want to encourage you to think about these kind of methods, we can do a lot of cool things that are basically hybrid methods that are living between those two extremes. And we are doing this, and I'm often quite excited about this. So, for example, we can run mock-up experiments. So meaning that we can create a platform that looks like Facebook or looks like TikTok, but we are running it as an experiment. And so at least we have the ecological validity of the platform looking and feeling like a real one. But we can go further to the ecological validity. So we can run field experiment. I have run an experiment on Reddit, for example, where we created our own subreddits and then we controlled them, but it was still the real Reddit platform. And so it was quite realistic. We can also let people install browser add-ons. So browser add-ons are possible to interfere with the browsing experience, for example. And then we can measure things and how people react to these changes. We can let people install mobile apps like on their phones. I have one study with an app called OneSec, where we changed the way people can open apps, and then it reduced their usage of social media, for example. So there are all types of ways to do that. And that's what we do in our research. We try to do these kind of hybrid methods and to cover the spectrum between experimental control and ecological validity to get at a more causal understanding of what's going on with democracy and digital platforms. And I don't have time today to give you all these studies, but this is like the team. There are many people working on this. And if you are interested in getting to know more about what they are working on, look them up and see what they have been publishing and what we are working on our website and so on. There's a lot of very cool stuff about this in there. Some of them you saw in the beginning. Pietro, for example, Kamil and Sami. Okay. And now let's move a bit to the practical part, because there's still the exercise. And I heard you will have a bit of time to work on this at the remainder then of the day. And I think the exercise is actually quite easy, and I think you might just want to have a look at it and understand what's going on. But it's about natural language processing, and also sometimes called automated content analysis. Who of you, just a show of hands, have heard about the term natural language processing? Okay, perfect. So you know what this is about. It's the way computers deal with language. And I want to give you a little bit of an overview of the ways that it works. I think that is very interesting, because in this area, there has been a lot of development. The large language models themselves are to some extent an outcome of natural language processing, and one of the most powerful tools that we have now. And for scientific purposes, I think there are multiple ways to look at it. I think, for example, there are descriptive methods on the top left. So descriptive methods that are not requiring a model, but they are just, and I think in that sense, they are very transparent, and using distributions or connections between words in order to give you an impression of the type of topics that are discussed in a text. So you probably know what a word cloud is. It's actually just a representation of the frequency of words. You see that on the right. There are many packages in all types of programming languages to do that. And then you see just the distribution of words. Basically here, the word news is the most common. What is very important when you do this is you need to do some filtering steps. So before you analyze your data in that way, you have to remove stop words usually, which maybe you know already, so that it's not the word and or the being the most common here. And of course, depends on the language, which are stop words. Another, I think, very interesting method is the keyword in context message or co-occurrence networks. And there's basically like this. This is like from a master thesis I was supervising. And sorry, this is in German because it was German text. But it is about terms and how they appear together. So it's about, if you look at a post or a sentence, you can calculate, you can draw a connection between two words if they could appear in the same sentence or post. And by that, you can construct such networks. Here you have like an ego network of the word. It's called Gutmensch. It was a political term being used in the debate. And then you can see around it with what kind of words it has appeared together. And it gives you a bit of a sense of the context. And for that, you don't need a machine learning model or anything. It's just counting the co-occurrences of a word. And so in the exercise, if you want, so I gave you some text data, and I already implemented a sentiment analysis and over time. But what I would invite you to do is also to do like a keyword in context or like this co-occurrence network, in case you have not done this before. And so just to see how the network structure of the words in the text is. And sometimes you do see then clusters of words that are kind of constituting a topic. And I think it's a very transparent way to do that. Then there are methods that are rule-based. There are
Is it us or is it him?
Scientific purposes because they are very transparent, because you know exactly what they're doing. And yeah, forget about the German text before, but there's a Python package called Veda, which is really good one. And what it essentially does, it counts the words that are positive or negative in text, as simple as that. And it's just a dictionary of words that are positive or negative. and then you count. Of course, this dictionary has to be up to date, and it cannot really capture irony and other things. But for example, Vader is developed for social media, so it does contain emojis and other things. And if you look at the bottom, it's an example. So you simply have this sentence here: the reform was a great success despite angry protests. And this results in a slightly positive score, because there are two positive words, great and success, and there's one negative word, which is angry. So you have 2 minus 1 is plus 1. And then you divide by 1, 2, 3, 4, 5, 6, 7, 8, 9 words. So you have like roughly 10% positive sentiment in this sentence. You do realize that this is, of course, very simplistic, and it doesn't understand the context of the text. So if there are, you can also say horrible things with positive words, and that wouldn't be captured with that. And I'm jumping over the machine learning and the supervised, unsupervised methods because, I don't think they are most interesting for now. I think what became, of course, interesting is large language models and how they do it. And I showed you the studies in the beginning that are using large language models for that, and they are sometimes called zero-shot or few-shot methods. Because you don't have to do yourself any training, because these are pre-trained. They are the models you can get either open source or proprietary by going to Claude or OpenAI or whatever. You get pre-trained models, and you can directly ask them things. And that is actually interesting. For the way we work with data. And as you remember, we, for example, do this us versus them and other things. And I'm missing a slide now, but I'm just telling you what I wanted to say is that what I think is very important if you use large language models for text analysis and NLP tasks is, like, ideally you use open source models for the replicability, okay? So the problem is that if you use ChatGPT, you cannot really say which exact model configuration you have been using because it's not open. So at least open weights and ideally fully open source for scientific purposes. But for that, you need some compute power, which is not always easy to solve. So that's one condition. And the other condition is I would always do it in a deductive way, so supervised. So basically not asking the LLM to say, tell me what is going on in this text, give me some categories or whatsoever, but you giving the categories. So let's say you want to look for a certain topic, then you specifically ask for the topic. And ideally, you do some few-shot annotations. It's already written here. So few-shot means you give already some labeled examples. So you do label basically a few posts yourself and then provide them as an example for what you are looking for. So a very deductive way. The problem with just asking open-ended, unsupervised is that the models have this agreeable bias, and they will give you always something. And the problem is, if it's not there, they will still give you something, and it's a bit dangerous for scientific purposes. And with that, I would be open for questions, and we can have a few questions around. And then I would invite you to try out a few things with the data that I shared. So the data sets are two different topics. It's about Minneapolis and what was the other one? Epstein. So these were two topics that were, of course, very, let's say, heated, debated in the US specifically, and the data is from Blue Sky. So Blue Sky, as you may know, is this open open protocol, AT protocol based alternative, let's say, to X or Twitter. And the good thing is here you can easily get data. So if you want to collect your own data, if you don't want to do Epstein or Minneapolis, you're of course welcome to do that yourself. You can go to the API and download it, depending on how much experience you have with that. And other than that, I think it's interesting to compare those two cases with some of these methods. I already implemented sentiment. I think you will have that already there. And you can try other things like topic modeling and similar. So yeah, that's it for now.
Well, thank you so much. First, a round of applause. Do we have questions from the audience? Yes, please. Can you shout? Either, whichever you feel comfortable with. Okay. But I think in the previous talk, we had some success with shouting, so.
Hi.
Hi.
Hi. First and foremost, thank you so much for the talk. My name is Jana. I am a misinformation researcher as well, looking at it from dynamical systems perspective. And I was curious, I just had some kind of clarifying questions about the time sequence and the diffusion of the misinformation. So was that only text-based information, or was it also images or like images of text?
Yeah, exactly. That's a very good question. So this specifically is text-based. There's a preprint, and you can have a closer look in how we exactly did that. We are currently working on transcripts of TikTok videos to get at least at that spoken stuff. But obviously, the whole internet now is full of images and videos, so we have to get there. And the models are becoming multimodal, right? So it's getting possible. It's just that it's even more computationally expensive, right? So you need even more compute power. And I think when you think about the claim level, and if you think about a misinformation claim, I think it's tricky to, if it's in text, in a picture, fine. But I mean, a picture can draw like an image of, let's say, a windmill killing a bird or something that may be missing. I'm not sure about this topic specifically, but that may be misinformation. But connecting this to a claim, I think may still be tricky. Maybe you can have an AI summarize what is in the image in text and then take this again, stuff like that. But of course, that's the direction we have to go.
Yeah,
that's clear.
So it's a little bit more gist based then, kind of like implicit. Kind of what do you take out of it rather than actually explicitly state it?
Yeah, in images it has to be, I think.
Yeah. Okay, cool. And another clarifying question that I had, if I can think of it right now on this spot. Oh yeah. So in the misinformation, you were talking about false claims and fake claims or fact checked. Is that really anything that is more on the fabricated side, so absolute falsehoods, or are we talking also about fields where it's very difficult to approach truth or veracity? So how do you kind of deal with that?
I think fake news detection and so on, misinformation is a tricky field.
Yeah.
And the truth is anyways blurry, and there are many topics where it's super difficult to make a clear cut. But because the discussion is so prevalent and everybody's talking about it, we thought, let's try to come up with a method that is, the method we have is, I think, the most conservative basically you can do. Is like, these are claims that have been fact-checked by professional organizations. So it means that these are quite false, yes. So unless otherwise, I think the fact-checking organizations wouldn't pick them up. And they are by definition, in that sense, already somehow viral or at least prominent, because otherwise fact-checking organizations wouldn't have picked up. So there's a strong bias in the way, in our ground truth, in a sense that we only take fact-checked claims by professional organization, but we, at least that is a kind of a common denominator where at least some parts of the population may agree that this is false.
Yeah.
Of course, there are still people who don't trust the fact checkers at all, and I kind of see to some extent the point. But I think this is like the smallest common denominator we were thinking about. I'm a bit skeptical if we will ever get to a point where we can actually grade like all the gray zone stuff. It's like too difficult. You can take a statistic that is true, but take it in a false context, and suddenly, is it still true or is it false? I wouldn't want to make that judgment, and I think we as scientists also have to be a little bit careful what we're doing there. So this is why we chose a relatively conservative definition, I would say, of false information.
Yeah, super cool. Thank you so much. I'm a big fan of your work and also the cognitive modeling stuff. So yeah, really cool to hear your talk, and thank you.
Thanks a lot. That's great to hear.
Thank you. Any other questions? Just maybe like I have like very quick question. It's not a specific question, maybe like more of an opinion question. Where do you see not sentiment, but like emotion detection from large text going? Like where do you feel like that technology is going towards in terms of like using LLMs or any other computation or statistical method? In like just to give you an example, like where are we heading? Where if we're trying to like differentiate fear dominant text from anger dominant text, for example, what is the technology going towards in that regard, do you think?
Yeah, exactly. I mean, this is part of this other project. And I think misinformation is, of course, a problem, but I think this type of emotional language, divisive rhetoric, and so on might actually be the bigger problem, because that's not about truth or false. It's more about polarizing the public against each other. And this is a political strategy. So I think it's super important to get at that. And it's a very interesting field because it's very polarized in the science itself. So there are some social scientists who are very enthusiastic about it and say now we can use LLMs to find basically anything in text and we can just ask about emotions and stuff. And then there's, of course, the other field that's very skeptical and says you can never ask a computer to say what's the language, what's the emotions in the text. And if they see LLM, they will reject your paper. So this is a problematic situation. And I think the truth is, as always, in the middle. So I think if we do it carefully, and that's what I try to say in the very end, basically, is like if we use replicable models in terms of open source, if we do human annotations as the few shot annotations, if we do careful checks with the human annotations, as well as giving very, very top-down deductive instructions, right? So making it very narrow what it actually finds. And that's what we do, for example. We don't ask, and that's important, we don't ask the bot to say, is this text instilling fear? Because that wouldn't make sense. Fear only humans can feel, I think. So it's emotions, right? But what we do say is, does this talk, does this post talk about a threat that people should be feared of? So it's more about the content of the text rather than what emotions it would instill. It's just like rather about what does the sender of the message, like the politician, have put in the text that may actually lead to fear. So and I hope this will work. What we realized is that if we ask these questions and then let students rate the same thing, we realized that sometimes, of course, the gold standard should be the human. At least that was always the case in the past. But then we realized sometimes that the students are not paying as much as attention as the bot. Because the bot reads the whole instructions. We give them all this complicated instruction. What is us versus them, definitions, examples, whatever. And they read it every time and then they look for it. And the humans, they don't read it anymore. They just look for it. And then they sometimes don't read carefully because they also lose attention after half an hour or something. So I think this is a very hot debate at the moment. Like, how does this change content analysis in the social science when we have the bots, the LLMs, I would say. So there's a lot of movement in there. I think in the next like 1 or 2 years, we'll see a lot of stuff happening there and a lot of papers coming out.
Yeah. Philip, thank you so much. One last time, can you like again repeat the data challenge in case some people missed what
Yeah.
we're supposed to do?
Yeah, the data challenge is not super specific, but you have two data sets there. These are two JSON files, yeah? And these two JSON files, they contain posts in a certain window of time on Blue Sky about two topics. So I did a simple keyword search. And one of the set contains the word Minneapolis. And as you remember, on the 7th of January, I think it was, there was this woman being shot by ICE agents in the US. And then there was a big outcry about this incident in Minneapolis. And that's why the posts about Minneapolis have this big jump in appearance on Blue Sky. And the other data set is about Epstein, and there was the Epstein files. You might have heard about that in December of the previous year. That where was the deadline of their release, and then they were released and they were not complete, and then people were talking about them. So I chose two topics that are different in nature, right? So one is an event that suddenly happened. No one expected this to happen in Minneapolis, the shooting, and then there was this big explosion. And the other one was like an event where people were kind of expecting the release, and then there was like an increase and then a decrease again of interest. So you can look at the time series in the first place. But because of the democracy topic, I would like you to look into the language. So you also have all the text of the posts. If you have the Python notebook, you can see already that I did some sentiment analysis. And that's one of the comparisons, the one comparison I did. So what topic is more negatively discussed on Blue Sky, and how does it change over time? And so the first thing would be just for you to explore that and to look at what I've provided there. And the next thing would be to add a topic analysis. So you can do any type of topic modeling. If you have access to a large language model, you can try the large language model approach by giving it a deductive task and asking it for certain topics, for example, security or Trump or other things that come to mind, to look for and see if they are discussed at the same level or differently between those two topics. And then you can combine this with the sentiment. So you could look at how different topics are discussed with which sentiment in those two data sets. So basically the challenge is compare those two discussions on a sentiment and topic level. That is rather open-ended. Sorry for that. But I hope the example that is already there will help a lot. And yeah, there's no right or wrong in this. It's more like explore the data.
Yeah. Philipp, we're grateful. Hope to see you in a conference in person quite soon. Thank you again. Let's give a round of applause again.
Thank you. Thank you for having
you so
me.
much.
I would love to be in Istanbul, but
We
I
have
will,
to
I will
bring
come.
you. Yes,
I will.
we have to bring you here. I'm working on it. So take care. Bye-bye.
Great. Thank you. Bye-bye.